Hello, I'm John with Forest Scientific, and we are going to do a little presentation on CNC routing. We're going to cover a little intro on our machines and some of our advantages over other machines in the market, and then we're going to go into some in-depth comparisons on tooling to use with a CNC router and strategies for holding down material, so this way we can help anybody that is looking to get a machine and anybody that owns any brand of machine, because what we're going to cover would apply to almost anything. And as we look here, this is our new logo. We had a rectangular shaped logo that said Forest Scientific. We are still Forest Scientific Corporation. However, with this new logo, it's just a little more high-tech look. And most of the people that have our equipment say, hey, I have a Forest or a Forest CNC, and this is a little better description of what we actually make. We have been featured on Mythbusters Junior. If you watch the last season, you'll see our routers and plasma cutters, not only in making parts to bust myths, but actually used in making the sets and parts on the sets for the show. It'll be really obvious if you watch it. So that was all made on our equipment. Forest Scientific is one of the oldest machines actually making CNC machines. There are a lot of startups out there, and we see many come and go every year. For over 31 years, we've been building CNC machinery, routers, plasma cutters, mills, lathes, water jets. We have lasers, all types of CNC manufacturing equipment. We have the greatest market share in the educational market, as well as machines in commercial markets. For instance, the current Mars and previous couple space probes were made on our machines. There were parts for the space shuttle being made on our machines. So for anything from high-end aerospace to sign making and furniture like Ethan Allen and Knoll Group and Steelcase and many, many other furniture companies have been making products on our machines for years. Our machines come fully assembled. We strive and are best in class at each price range. Many of the lower costing machines that we compete with, even under $30,000 range, come as kits, and you have to spend 40 to 80 hours building these kits, where we offer a complete turnkey package, including a fully assembled machine, the computer, the CAD/CAM software, on-site training, and are competitive with all of these other kits. And so even if we were a little more expensive, it'd be well worth it, because what teacher has 40 to 80 hours to spend of their own time building these things on weekends and nights to actually make it happen? So we offer success from day one because of the on-site training, the fact that it comes as a fully assembled machine. Because we've been making machines for so long, we have superior technology in them. We've partnered with the right suppliers to make the right parts. And we also, in addition to building new machines, retrofit every other brand. So if you're stuck with an old machine and you don't have enough money for a new machine, we rebuild every brand. And we've learned so much because we've worked on every brand out there. We know everybody's benefits, everybody's deficits, and we incorporate that knowledge into our designs to make our machines superior. We also have the best warranty in the business. Now, all warranties are not the same. A warranty is very important, and an on-site warranty is even more important. Most of the warranties we compete against are 1 or 2 years, and that just means you'll get to talk to somebody on the phone. If you need somebody to come out, most people tell me that they spend anywhere from $3,000 to $7,000 to get that support from the original manufacturer. Often for that same price range, we will actually do a complete retrofit, and we put an 18-month on-site warranty on machines that we retrofit, and actually it's less than having the original manufacturer come in. And we do a lot of machines that are actually still under the manufacturer, another manufacturer's warranty, because we can do it more cost effectively and make that machine much easier to use. Our machines also all run on industry standard G&M codes, so they actually meet industrial and educational standards. A good bit of our competition has proprietary languages that don't actually meet these standards, so you're not really preparing students for the real workplace, for industry. So you want to have a machine, if you're going to be preparing future workers, that is going to work like other machines. And a lot of our machines really compare to machines costing far more. You don't want to buy a kit that's in a box. Otherwise, you're just buying another job that you're not getting paid for. This is a Mighty Router. It's a tabletop machine that we often put in middle schools because it's fully enclosed. Obviously, it's fully assembled, but it's also fully enclosed. We also put a lot of these in CAD rooms as a clean room type machine. We have several models that are fully enclosed. This is our FabBot series, which are very cost-effective tabletop models. They can either come just as a tabletop machine or in this optional enclosure and stand. And again, these are full turnkey packages, so it includes the computer. It is a working machine, not a box of parts that is another job for you. This is our FabBot platform series. And our FabBot platform and our Titan series are made of structural aluminum, which are significantly stronger than other machines in this price class that are not only kits, but come as bent sheet metal or just angle iron bolted together. And because of this construction, you can see the gussets and so forth give it reinforcement to ensure its strength and integrity. And if you scoot along, you're not going to mess it up. Also, one major difference is our machines all come with THK profiled linear rails and bearings. Everything else in this price range is, and this is in the $10,000 to $15,000 price range here, come with basically little wheels that run on angle iron or duvet V-shaped metal. And this is built like a high-end machine tool, where those are just running cheap little $2 wheels. There's a big difference in the quality. A student can't bump this out of place. A student can bump a machine built with little wheels out of alignment very easily. And then that creates more work for you and downtime in your classroom. So all of our machines are built to ensure reliability and dependability and not having to work on them all the time. A lot of companies have websites so that users can help each other out. We have lifetime toll-free tech support. You call us up on the phone, we'll guide you through what you really need to know and get that machine going if you forget something or if something were to happen. However, we have so little trouble that we don't need to push our support onto other users. We help you. Here's the Titan that I mentioned earlier. Again, it's heavier duty. The aluminum ones are cost savings because of this aluminum being less expensive than steel. It's also a huge advantage if it has to go up or down stairs and in tighter places where it might have to go up on its side to get it through a door opening. So it gives you some other options there. The Maker Fab and the HS with the next slide are our two most popular series. They are of welded steel, totally welded steel construction. It's built like a tank, very heavy duty. You can expect to last 20, 30 years. And we make our machines so that as the technology changes, we can often just change one board and upgrade with the technology as it goes. So it's inexpensive to keep it running for the long term. Where other machines that we retrofit, we actually have to put a lot more into keeping them running. All of our machines are fully built in the United States, actually in Pennsylvania and Arizona. And we're not using Chinese frames and so forth, so you don't have to worry about parts coming from China. You don't have to worry about when you order from us, we actually fill that order, and you're not waiting for something to come off a boat from China. And the HS series is the top of the line. We especially put these in high school and vocational school programs, university programs. I strongly recommend a vacuum table system if you're doing cabinet making. If you're doing robotics, we often will offer it with a aluminum T-slot table, and it's like a huge milling machine. So you can be very competitive in programs like FIRST Robotics with our equipment. The closed-loop servo system allows you to run at higher speeds and maintain accuracy. Now, all of our machines have more powerful motors than what most of our competitors offer. So we have 1,200 ounce-inch motors. So if we were to draw if this is speed and this is torque, we're starting out at 1,200 ounce-inches, and as you get way out here in the speed curve, now you're down to about 300, where most of our competitors are. And where they're starting out here, they run out of steam much faster and don't get to the same types of speeds that we can offer. This page is the converter table, which is a one-of-a-kind type machine. We're the only company that offers something like this. The converter table has a tabletop that is removable, revealing the water table, so you have a way of actually holding wood that you're going to cut. A lot of machines will say they can do both, but how are you going to hold it in place to actually cut it? You can't. Where on our machine, you have a clamping table to hold the wood in place, 2 bolts to take off the router, and 2 bolts to move the plasma head in, as you see here. And then there are 3 bolts on each side. On a 4x8, there are a couple more. But basically, with a power drill, you can zip these bolts out and do the conversion in about 10 minutes. I don't recommend this if you want to do plasma 1 hour and routing the next hour. You're going to lose too much time in that conversion. It's fine if you're going to have a week of plasma cutting and a week of routing. It's often used in cases where the amount of floor space just doesn't allow 2 machines. Another advantage is if you want both machines but don't have enough money this year, a lot of people will start out with a converter table, and then when they have more money, they'll buy a router with a vacuum table so that it has all the deluxe features, and then leave this set up as a plasma, so you have the best of both worlds. And then you have an additional router that you can always go back to later on. So I just want to give an overview of what we actually make before I get into the other part of the training, actual training, because a lot of people say, well, I had no idea that you did all of that. And I figured we need to show this part of it as well. Then we're going to get into tooling and ways of holding material in place while you're cutting it. We're going to begin our session on the tooling and fixturing secrets. Always need to choose the right tool for your job. Different tools have advantages, and we're going to go into some of these. This here is a spoil board bit. This would allow you to totally plane off a spoil board so you can get more life out of it. If you're making a vacuum table, to make it all perfectly smooth and perfectly flat. MDF, especially anyone in a more humid environment, which especially the East Coast, Southeast, and anywhere else in the country, if it's a rainy day, can get quite humid. And your MDF will swell and not be perfectly flat. So by being able to take this bit, you can smooth it off and make it perfectly flat. These bits are all ball nose cutters, and these are all based on the fluting and an up spiral. These are great for doing 3D work. So if you're doing really fine detail, you could use an 1/8 inch bit. I use the 1/4 inch bit. Oops, I went too fast. 1/4 inch bit for the majority of things because I don't want to have to change bits if I'm not using a machine without an automatic tool changer. With an automatic tool changer, I probably will use a lot more bits, but otherwise I will do the 1/4 inch to save time of changing bits the most. And then the 1/2 inch ball nose for those much larger, less higher detailed type pieces. So mainly for 3D work, and you can also use it for effects where it kind of looks like it's sandblasted, because it'll leave extra stripes along the way of something, depending on how much you overlap the bit. If you have more, say a 50% overlap, there'll be little lines left in the cut. If you're 85 to 95% overlap, then it'll be extremely smooth. These are V-shaped or conical type bits. So this is a 1690 bit that we get custom made, and it's great because you have the very sharp point on this end and nearly as sharp but a little bit wider at this end. This is great for V carving and very fine lettering. This bit is a 10-degree conic. And this bit was really a result of, we had a lot of people wanting to use a 16th inch bit, but a 16th inch bit breaks very easily. And so this bit is a 16th inch in diameter on the bottom, but yet it doesn't break because it has the strong solid carbide. So these two are both solid carbide bits, and this one's at a 10 degrees, so you can get fairly deep before it starts getting wide. And then these are carbide tips, so it's a 60-degree angle, a little bit wider. Actually, this would be a 90 degree, a little wider, and then a 60 degree, a little sharper. You can see a little bit better view of each of these bits here. You want to use bits that are plungeable. So this straight fluted bit, this is carbide tip, has carbide tips on the two edges and across the center. If this is open and you try to plunge straight down, there's nothing to remove the material. So you always want to use a plungeable bit. These are spiraled bits. And so this one is an up spiral because you can see as it rotates clockwise, it's pulling the chips up, and this one is pulling it down. And notice the flutes go all the way to center, so these are also center cutting bits. Now, I often like to use a down spiral because it's pushing on the wood, and if you're using something thin, it helps hold it in place. And it also has less fraying. If you're using an up spiral on the wood, sometimes it rips and tears, and it's not as smooth on the surface. Where the down spiral is pushing down in, it leaves it very smooth. Again, you can see how the flutes go all the way to center, so these are plungeable bits. Fixturing techniques. Some machines you can set them up with a clamping system. So here we have stops and then these movable clamps. We can put them in the holes here. We have some machines that have aluminum slots embedded into the tabletop, and you can move the clamps around that way. In using a vacuum table, sometimes you need rubber to seal and provide a better seal and also a little more friction to prevent it from moving, especially if it's a smaller part. If it's a plain, say for instance, you have a 4x8 sheet of MDF down on the bottom, you could have 1/2 inch, 3/4 inch sheet on the bottom, put another sheet on top of it. As long as your parts are bigger than, say, 10 by 10 inches, everything's going to hold really well. Especially using a 1/4 inch down spiral, you can get by with even much smaller parts and they'll never move. But as you get into smaller pieces, and that's when some of these other fixturing techniques will come to play with vacuum. And one way that we will hold it better, especially with like plastics, we'll use a material like this where it's actually rubber, it's actually adhesive, so you can glue it down to a piece of wood, and the holes will allow the vacuum to go through, but the rubber provides additional friction to prevent it from moving. We use this material in our vacuum table. So we have a grid pattern that you can put this rubber in around the perimeter of the wood that's going to be held. And when you turn on the vacuum, it just sucks right down and holds it very well directly in place. Sometimes we will need to use a spoil board. So if we are going to cut all the way through, as you can see on this routing table, we have a spoil board that will have some holes in it, and then it'll suck right down through to make it. Sometimes we'll use this closed cell weather stripping, which you can get from different places. We have it in our catalog, but closed cell weather stripping, usually you use 16th inch up to 1/8 inch thick, but generally 16th is best, and that will smooth out. For instance, if you are using solid wood, maybe it's oak, it's a very open grain, and you've put it directly on MDF, it may not hold because it's not sealing the air enough. Where if you have this around the perimeter of where the wood's going to be, and sometimes we'll even drill a hole in the center of the spoil board underneath, this will allow it to perfectly seal and make up for what may be lost in the grain of the wood. Here's an example of that. So this gasketing is all the way around the edges, and in this case there are some slots to allow extra air to form and multiple holes in making this chair seat. Here's another way of doing it on a sheet of melamine, and there is the rubber on the outer edge, and then some additional ones so that when the allows more of like a vacuum chamber here, but it also keeps it from sucking down in and making the wood unsquare on the piece. We also do it with acrylics in many cases. All depends on the part you're making. You can be really creative with how you are holding that part in place. Here's another one similarly. You can see a little more intricate pattern, so you can get the most of holding the material down onto the table with vacuum. If you're going to make onesie, twosie pieces, just use a couple drywall screws and hold it in place and leave a little tab you cut off. But if you're going to make 100 or even dozens or thousands of parts, then it's worth it to take the time to make a vacuum jig, as well as teaching that process. Often the jigs and fixtures person is the last person to be let go in most manufacturing companies. Here, you can get sheet rubber, and usually what we'll do is adhesive it down with a Super 77, and you can create a pattern and just suck it right down in. There are also different types of blocks that will hold the material up, and these work really nice especially for like doors and bigger, heavier parts, and where you may have sometimes we'll make a machine where there's bits that are actually coming in off the side, and so we need to get it way up off of the table. And in those cases, this type of a vacuum block is great for that purpose. And they'll have a little hole here. I believe I have a video coming up, and I'll go ahead and play this example of it.
Okay, so this pod is there's air underneath it to suck down with the vacuum, and there's this like little marble here. And when the board presses down, it then allows the air to flow through that hole. And so when I set the board on with the air on it, it's now holding it very firmly. And if it's a longer board, you would need it held from two ends to keep it from twisting and turning.
Now we're going to have a example from one of our customers cutting out a part, and then we're going to go over other projects to give you ideas of what can be made on a CNC router. Now I want to give you some ideas of projects that other schools have made to utilize a router. So here you can see all this 3D work for making this box. CNC wood lathe is actually used for this. CNC router for making the table top and bottom, then a CNC wood lathe for making the pedestal. This sign done with the CNC router. This one's involving CNC wood lathe. This truck is actually made out of MDF, and it was actually made by someone entering in a competition sponsored by Chevy Truck for a birdhouse bird feeder. The bed of the truck is the bird feeder, and on the one side, the window is actually a house that a bird can actually get into and live in this truck. And CO2 car is another popular type school project. This was done with a router and then laser engraved to finish it. There's another laser engraved project. So a combination of different machines. This was also laser engraved. This could also be done with a router. This is at an entranceway of the school, and each one of these raised panels represents an extracurricular of the school. So here's chess club, football, not sure, that might be fire or something, some other sport over here, basketball, carpentry club, and so forth. And so they were able to create something that looks really well and promotes their program because everyone sees it. They also redid all the bulletin boards. Instead of having this basic metal ugly look, they made these really nice bulletin board frames. Here is a front desk of a school where they, instead of having that plain pinkish, greenish, whatever color, they made all these raised panels, and then they put their school mascot in them, and these were all cut out in 3D on the CNC router. Here's a closet, and you can see the engraving here. So this is done with probably the 10-degree conic would be ideal for this particular process. Another one where there's engraving, this chessboard. This I'd probably do with either the half-inch bit or a quarter-inch bit. And then this would have been probably done afterwards as a secondary operation to get this profile with an inverted router table. It could also be done with the CNC. This is done with a laser. Sometimes these fine things are awful hard to do with a scroll saw without breaking them. Mud ping handles done on the CNC wood lathe, where the sides and the shells were actually done on a router. Vinyl sign with a good message. Another laser project. With lasering, you can actually get really, as you can see, very high quality photo, realistic type pieces. This is a piece of Corian, and what they did is they used the 6090 bit to make a very fine line cut, and then they inked it to give it the contrast. This is actually a candy dispenser. So what they do is they fill this in with M&Ms, and then they tilt it back. And right now this piece of plastic here, it would be sealing it off. And when they tilt it back, it's able to poop out the M&Ms. This is called the Poo Bunny. Here's a picture frame. Again, this would just be cut out with a quarter or half-inch bit. Probably quarter, based on the way the radiuses look inside of here. Skateboards, longboards have long been popular projects. Another one. This is a guitar that's actually a clock. And they made many, sold them for $35 a piece as part of a free enterprise and manufacturing project. And there's the final rendition of it. Raised enough money to go to skills competition. This is a simple machine. It was actually done on a little mighty mill. Some other ones here. Wood lathe project, and this probably, since it's square, they could have just done that with just a saw. Another laser engraved photo. Another laser engraved clock. Now, clocks are great to be done on a router and or laser or both. Lots of times I'll cut out my shape with a router, and then I'll add some additional pictures and things to make it prettier with a laser. Laser engraved marble. Another lasered piece. Probably the outer shape could be done on the router, and where the laser can only cut a smaller thickness, the router could be used for the outer shape, where the laser can cut this finer detail, and then here it was glued together. And actually, let me back this up. This could actually be done if this is all the same wood. Now, there are two different pieces of wood here, but this could be done all with a router with an 1/8 inch bit, and you just pocket along here as well. Laser engraved mirror, another lasered picture frame, rocking chair similar to what was done in the video shown just a little while, all put together without any hardware. Great profitability project. Most schools will sell close to 100, and they're profitable. Another laser engraved piece. Adirondack chairs. We have law schools making various types of Adirondack chairs on the router, and sometimes engraving a customization with the router, other times engraving a customization with a laser. Here's a routed clock. Clocks are always good sellers, typically selling anywhere from $25 to $35 a piece, even something as simple as this. Drawer front with a laser. This is routed in 3D using a 1/4 inch ball end mill, as I mentioned earlier. Another vinyl sign, raised panel door and vinyl sign added together. Wood lathe project. This cribbage board coffee table with drawers, all done on the CNC router. Routed and lasered. Plasma cut project, another plasma cut project. There are a couple of different things here, different machine processes. And sometimes you can take something that's plasma cut and then inlay it into the wood and get another great effect. This wine holder, or juice holder as I call it, to be politically correct with our own students. This pool table made by the students here. It has engravings as well as various parts made on the CNC router. Little height gauge plus clothing rack. Another 3D piece and turned into a box. Bookcase. Anytime you can put a student's name on it, they're going to be more interested in it. All the datas and so forth of making this can be cut out on the CNC and quickly put together, make 1 or 100 of them once that first one's designed. Another piece here. This one won a blue ribbon at the Los Angeles County Fair. You can see some of the CNC work here, as well as various parts that were cut out on the CNC with the radius and so forth. These tables make the two sides. They slide together. The router, the tabletop, and it all just fits together, gets glued together. A little wine rack in the back here. Some more boxes and things. Guitars, electric guitars. We have free workshops on electric guitar making and beginning to do some acoustical workshops as well. You can see the great inlay work done on the CNC router to make this desk. Beautiful workmanship. Headboards, footboards, Chinese checkers, some more 3D type work, and then glued together to have the beauty of the two different types of wood. Much nicer than the previous pool table. You can see the CNC lathe work plus the routed work together there. Some more 3D router work to make this what looks kind of like a coffin. This cut out on the router, these cut out on the CNC wood lathe, and then pinned together because the lathe is only their lathe is only 36 inches, and many are only 40 inches long. More work there. Light boxes, you engrave it, the light just stands out beautiful, it just glows once you turn the lights off. kitchens. A lot of schools making kitchen counter cabinetry and cutting out sink cutouts and so forth on the CNC. This is a more basic, simple one. This is actually a wooden baseball glove carved out in 3D. Much fancier cabinets. This particular school does a project every year where they make, they'll go into town, and I've had a lot of teachers that will say, oh, we don't want to compete with anyone locally. Well, they're doing it right, because these students often will do kitchens, bathrooms, in this case, a laundry room, and they rip out the old cabinets, they put in new, and they know the whole process. So this particular school in southwestern Kansas has companies not only in Kansas, but Colorado, Nebraska, Oklahoma, and Texas, and even some from Missouri trying to recruit their students because they actually know what they're doing because they've done it. This armoire here, milling machine, what you call them, belt buckles. This gun cabinet, these antlers are actually 3D carved out of wood with the CNC router. Magazine rack, and again, this inlay is all done with the CNC router. In our software, it's really easy to do inlay. Our software will automatically compensate for the tool and go through. Little wine rack, similar. So hopefully this will give you some ideas of things that you can make in a CNC router, and I'm sure spur many more ideas of things that you can do.